Hello everyone. We are going to discuss section 3.3 on molarity. One thing I want to mention before we jump into the learning objectives, this is a section that I actually really like the way they have placed this in this textbook. It makes a lot of sense because it is an important concept, and in many textbooks this is placed in a position a bit later where it gets, I think, lost with some of the more complex things that you're looking at in those later chapters. And I think it does make a lot of sense to introduce it a little bit earlier here. We are going to divide this section into two parts, as we've done for some other sections, because it is such an important concept, and I want to explore some of these in a bit more detail because of that. So I will discuss here the learning objectives we'll be looking at in this video, and then in a later video we'll look at additional things. So we want to be able to describe the fundamental properties of solutions and calculate solution concentrations using molarity. The last learning objective we will have in a separate video. I want to start this section by having a little bit of a rewind to to module 1 when we talked about different types of substances. So we had pure substances and we had mixtures. The start of this module 3 has been about basically pure substances. So we've been looking at finding the percent compositions of elements. In this section, we'll be looking at a particular type of mixture, the homogeneous mixture, and looking at how we can discuss how much of a substance we have in a mixture. And kind of as a preface to that, we want to discuss a little bit about what a mixture is. So in a mixture, you can have a variety of different compositions. So you can, for example, we're showing in this picture, they're showing somebody preparing a cup of, I guess it's coffee, and they are putting sugar into that coffee. Now, some people might not want sugar in their coffee. Some people might want more sugar in their coffee than others do. So there is a variety there in composition. That means that the coffee is a mixture as opposed to a pure substance. Also, just in general, when you buy a coffee, there's lots of different possibilities. You can have it stronger, you can have it weaker. So coffee is in general going to be a mixture, and we want to be able to talk about how much of it we have, even though it is not a pure substance. So that's what this section will be about. So we can use the word solution as being identical with a homogeneous mixture. So we had to define the homogeneous mixture as a mixture that has constant composition throughout. It's uniform throughout. So basically it doesn't have chunks in it. We can't look at it and know that it is a mixture. We have to know something about it in order to know that, because we can't just decide by looking at it. So solution is another word for homogeneous mixture. Within a solution, we will have different components, and unlike with a compound, we don't have a formula for that because they can vary. So we keep track of their concentration, so how much you have of each of the things that are present in the solution. There are lots of different types of solutions. We can even have solid solutions. So for example, metal alloys are an example of solutions in many cases. But for this course, we will mostly focus on what we call an aqueous solution. And in an aqueous solution, we have something dissolved in water. So that will be the major focus. And we're saying here that water is the solvent. The solvent is whatever part of the solution you have the most of, whichever one you have the most of. And the book is saying here the medium in which other components are dispersed. So whichever thing you have the most of is the solvent. And so you want to remember that that's what we mean when we say solvent. And the solute is whatever else you have. So you will have one solvent. You will have at least one, maybe more solutes. For this course, we'll mainly focus on looking at one solute at a time. We can discuss how much solute we have in relative terms such as dilute or concentrated. So having a very large amount, we would say, is concentrated. Having a very small amount, we would say, is dilute. But we can also measure this in terms of an actual quantity instead of just having a qualitative description. We have ways of measuring these things. And the way we'll be using in this course is molarity. So molarity is a measure of the concentration of a solution. And we define molarity as moles of solute per liter of solution. Okay, moles of solute per liter of solution. A few things I want to point out as being a key here. One is that we are using the mole concept, the same concept we've been using to describe quantities throughout this chapter. So it continues to be important. The mole we're talking about here is the same mole that we've been talking about since section 3.1. So if we needed to do some kind of conversion involving the mole concept, we would do it in this same way that we've done some of those others. And then the other one is the liters as liters of the entire solution. And that's often a very convenient way to measure this in the lab, because we are often, maybe if we're preparing a solution, we have a certain volume that we need of the solution, and so that we would go about preparing it in that way. We'll see a bit later there are other ways of measuring concentration as well, and we'll talk about that in a later section. So we can do a variety of calculations using this definition of the mole concept. We can, this first example will be discussing finding the concentration if you're provided the moles in the volume. So hopefully that seems pretty straightforward. More common though going forward is using it as a conversion factor. So this next example will be doing that. So using, so you'll have to refer back to this problem's answer to do the next one. But using it as a conversion factor, using molarity itself as the conversion factor. Okay, so you'll see some examples of that. Using it, it will often be also incorporating ideas from previous sections. So in this example, you're not given moles, you're given mass. Okay, so you'll have to find from mass, you'll have to find moles in order to then find molarity. Okay, so there will be some connections to previous sections as well. So I would highly recommend going through some of these examples, as well as some of the examples. I believe there's a worksheet that is about molarity as well. Going through those examples, ask questions if you would like a more detailed video on any of these. There is a mention here of using guard digits, and the idea here is that when you have calculation with several steps, you typically, if the steps are all multiplying or dividing, it's typically better to round at the very end instead of an intermediate step, which could cause a bit of a rounding error. Generally, I'm not going to be too concerned with that for this course, but it is more correct to do the rounding at the end as opposed to in the middle. And this another example of using the molarity as a conversion factor. Again, there will be some examples on Canvas of worksheets with similar questions. My recommendation would be to go through each of these examples in your textbook, try them out, make sure you're able to um, get to the answer without consulting the solution. And then maybe do a similar question on a worksheet, see if you can figure that out. And then if you would like additional help, please post a question on the discussion board, and I can either find or create a video of solving similar problems for the ones that I see several questions about. We will have a separate video for the second part of this section for the dilution of solutions.